Alright guys, so today we are going to talk about geometric series, and not just the ones that we talked about on last Thursday, but we're going to be talking about infinite geometric series. We mentioned when we did arithmetic series that you can't have an infinite arithmetic series because you're always either adding or subtracting one more number. So when you add or subtract, you can always find one more. Even if you get off what you might consider the infinity mark, you can still add two more, you can still add 7 more, you can still subtract 2 more and consistently get a larger or a smaller number. When it comes to geometric though, if you have a number that is bigger than 1 as your R value, as your ratio, that means the number is constantly going to get bigger. So you're constantly going to multiply by 2. That's always going to give you a much larger number. But what if your R value is not a number bigger than 1? What if it's a 1/2? Because you're going to keep cutting something in half again and again and again, and it's going to make it smaller and smaller and smaller. Those will eventually get to the point to where you're adding such a small amount that it's not going to make a difference to the overall number. So when we look at things in terms of infinity, we have this thing called convergence. And convergence is when you've got that number for your R value that's going to be less than a 1, so that series is going to take big numbers and gradually make them smaller and smaller and smaller and smaller and smaller and smaller. And you're going to do that infinitely so that you're finally adding these tiny little amounts that add up to nothing, really. So those type of series, you can actually find a sum for at infinity. Now, that means convergence. Divergent is any series where the numbers aren't going to get tinier and tinier and tinier. They're going to blow up and get bigger and bigger, and those we cannot find a sum for because you're constantly adding a bigger number, so that actually makes a difference. So, to determine whether you're looking at a series that is either convergent or divergent, the first thing you have to do is look at your R value. Like I said, if your R value is bigger than 1, it's going to diverge, it's going to get bigger and bigger at the end, and if it's less than 1, that means you're cutting it in half or in thirds or something. You're making the number smaller and smaller and smaller. So, when you're looking at these sequences, what you should be doing is finding your R value first. So, convergent if it's less than 1, divergent if it's greater than 1. And of course, we always talk absolute values because we know that we could have a negative R value just as easily as a positive. So, what you need to do, and if you remember back to when we did geometric sequences, to find the R value, you always take the second number and divide it by the first number. So if you take 36 and divide it by 54, the simplified fraction that you are going to get is 2/3. So that means 54 times 2/3 is going to give you 36. 36 times 2/3 is going to get you 24. 24 times 2/3 is going to get you down to 16. And it's going to keep doing that again and again, making it smaller and smaller and smaller. So your R value is 2/3. The absolute value of 2/3 is definitely less than 1, so this series is convergent. Now the next one, you're going to do the same thing. What you should be able to start noticing right off the bat is if your series is getting bigger and bigger and bigger, that's going to diverge. It's going to be considered divergent because you're never going to be able to find a sum at the end when the next number you're adding is much bigger than the one beforehand. So for the second one, when you do 12 over 8, it's going to reduce to a grand total of 3/2. And of course, if your R value is 3/2, 3/2 is greater than 1. So this is divergent. So at this point, you could probably pause the video and go ahead and do the next two on your own. After you're done pausing, when you look at the next one, again, it's going up, so most likely this is going to diverge. Go ahead and do the second divided by the first to find that out. Your R value is again 3/2. So with that being said, you've got a divergent sequence, or a divergent series rather. But for the last one, you've got 50 as your second term and 100 as your first term. So that means each time the number's getting cut in half. So if you're going to consistently cut it in half, that means I'm going to add a 12 and a half, and I'm going to add a 6.75, and it's going to, or a 6.25 rather, and it's just going to keep getting smaller and smaller and smaller, and you'll eventually get to the point where you're adding like a 0.025 or a 0.0000025, and those aren't really going to change your sum very much in the long run. So this is going to be a convergent sequence with your R value being 1/2. All right, so that's all well and good. You guys can now identify whether a sequence is considered convergent or divergent. But what if it is convergent? Can we actually find the sum? The answer to that is yes, we can. And so if it is convergent, you can find the sum using this formula right here. Now, this is on your SOL formula sheet. So it's absolutely fine for you to use this. You don't have to have it memorized, but know that it's there.